The hydraulic power pack is the energy unit of any hydraulic system in the field of automation. The pump can be considered as the heart of this supply unit, which supplies the volume flow for the actuators, such as the cylinders or hydraulic motors. In automation, pumps are mainly used for working on the principle of positive displacement. In this video, we take a closer look at the gear pump, which is installed in our hydraulic power pack. The external gear pumps are compact, have few mobile parts, and therefore are relatively inexpensive. Two gears, usually equal in size, mesh with each other inside the housing. The drive gear is an extension of the drive shaft. As it rotates, it drives the second gear, called an idle gear. When the pressure becomes too high, the oil comes up through the bearing clearance and goes through the notch back to the inlet. This way the pump protects itself against being damaged, but the volumetric losses also increase with high pressure. Let's mount the parts together once more and watch how the pump works. When the wheels rotate, the tooth gap is closed by the opposite tooth, but when a tooth emerges from the gap, negative pressure occurs. The bigger the teeth and the higher the pressure, the pulsation of the pressure at the outlet of the pump gets worse. To prove our statements, we conduct a test on our hydraulic power pack. Right on the port P, we connect a pressure sensor. The signal of this sensor we can see on an oscilloscope. We can adjust the system pressure using the pressure relief valve, which is a part of our hydraulic power unit. Indeed, the pulsation seems to be proportional to the pressure. In addition to the mechanical losses due to, for example, friction, every pump also has oil losses, called volumetric losses. Oil trapped between the gears and leakage reduces the volumetric efficiency of the pump. The theoretical volume flow, that means the volume of oil that the pump should deliver per minute without considering the volumetric efficiency, can be calculated very simply. By the way, the volume per revolution is a constructional characteristic and therefore of fixed size. That's why gear pumps can be categorized as fixed displacement pumps. So the total efficiency can be determined by two ways, either via the multiplication of the mechanical and the volumetric efficiency, or via the relation between output and input power of the pump. The following measuring table shows the volume flow and the mechanical input power in dependence to the system pressure. The other values you can evaluate. What you see is that the volumetric efficiency is getting worse with growing pressure. And of course, the total efficiency curve must always remain under the other curves. You can download this Excel file from our webpage. The link will be in the video description. You can get some basic information from this typical data sheet. To choose the right pump, you should first know the necessary volume flow to drive your hydraulic actuators. How do you determine the volume flow of one of these pumps? It's easy. The rotational speed, which has to be within the permitted range, should be known, and you can apply this simple equation, which we already discussed. Also interesting, this table distinguishes between three pressures. Peaks in pressure can occur due to external load, for example. A check valve at port P or a surge tank can protect the pump from the pressure peaks. External gear pumps are widely used in modern hydraulic systems due to their high performance and long service life. This pump consists of relatively few parts, with the advantage of low purchase and maintenance costs, but they are also considered to be rather noisy. This pump belongs to the fixed displacement pumps. Liquid enters the suction port and travels between the teeth. The crescent divides the liquid and acts as a seal between the suction and the dissection port. In addition to their wide viscosity range and wide temperature range, the internal gear pump is almost non-pulsating. They can be birotational, which can be used to fill and pump out vessels. This pump is used within a medium pressure range up to 300 bars. The name gerotor is derived from generator rotor. They belong to the internal gear pump without crescent. The two pairs are in sliding contact. One gear is driven by a motor, the other is the idle one. The gerotor gear has one more tooth than the internal gear. This pump has few parts, therefore it is highly reliable and of small size. You find this pump in lubrication systems and in low or moderate pressure hydraulic applications. You can find more information about hydraulics on our website. Subscribe to our channel and never miss a new video.